Today we are going to learn about cube roots of a number, finding the cube root of a number by factor method. So, in a nutshell, when you're talking about cube root of a number, let's take an example of 216. So, when we say we find the cube root of 216, the cube root is 6. So, the number 6 is what we are calling the cube root. Because when you multiply 6 by 3, when you multiply 6 3 times, it will give you 216. So that is the cube root. So we'll be looking at finding the cube root of a number by factor method. So when you're talking about finding the cube root of a number by factor method, we are going to start with an example. So this is our first. We'll use 8 to find the cube root of 8 by factor method. So first things first, we have to find the prime factors which make up 8. So 8 can be given by 2 times 2 times 2. So this one is quite simple. So these are the prime factors that make up 8. So when you are talking about factor method, remember that you need to use prime factors of a number. So 2 times 2 times 2 can also be expressed as 2 power 3. So this 2 power 3, when you divide each by 3, you will get 2 power 1, which is the cube root. So I want to introduce an aspect that we call a perfect cube using this example. A perfect cube. So when we are talking about a perfect cube, it means that for a number, in specifically the prime factors that we are dealing with, their powers have to be divisible by 3. In this example, 8 is 2 times 2 times 2, which is 2 raised to power 3. So when you divide power 3 by 3, you get 2 power 1. So 2, this cube root is a perfect cube. So I'll take another example. Number 300, we find the cube root of 343. So, to find the cube root of 343, we'll need to determine the prime factors that when you multiply them, you get 343. So, these prime factors are 7 times 7 times 7. So, when you multiply 7 by itself 3 times, you will get 343. That means that 7. So you divide by 3. You divide the power of the number by 3. You get 7 times 1. 7 power 1, that is. So this is the cube root of 343. Now for a number with varied cubes, I'm still going to use this example of 216, but now I'm going to use the prime factors of 216. So the third example number 3, we find the cube root of 216. So when I break it up into its constituent prime factors, it is 2 times 2 times 2 times 3 times 3 times 3. So how we arrive here? From here you see that directly the cube root of 216 is 6. So we have 6. 6 to get 6 is equals to 2 times 3. So that's why we are getting the 2's and the 3's. Here there are 3 values of 6. So we'll have 3 values of 2 and 3, that is rather 3 values of 2 and 3 values of 3 for the whole cube root. So we get 2 power 3 times 3 power 3. So for us to continue, we divide the powers by 3. We divide the powers by 3. We get 2 power 1 times 3 power 1. Then we get 6. So we have arrived at our first answer, that is 6. So when you look at the steps carefully, when you get here where we have the prime factors, you arrange the prime factors such that their powers are divisible by 3. 2 raised to power 3, 3 divided by 3 is 1. So that's divisible by 3. So we have that this is what we call a perfect cube. If you need to remember that. So I'll continue giving examples. So we find the cube root of the following. First one is w raised to the power 6 y raised to the power 3. So when we are looking for the cube root of this value. Here we have used it is an expression rather than real values, but still we can be able to find the cube root of this expression. This is the same as w times. This means the same. So when we're talking about w raised to the power 6 times y raised to the power 3, w raised to the power 6 means that we will have to multiply w by itself 6 times, and y raised to the power 3 means that we will have to multiply y by itself 3 times. So we don't need to break up w into 6 values. We'll just go directly to finding the cube root, since we already have been given the powers, which will be w over 6 divided by 3 times y over 3 divided by 3. So we'll get 6 divided by 3 is 2, so it will become w raised to the power 2 times y raised to the power 1. So the cube root of this expression is w squared y. So another example. Find the smallest value of p such that 288p is a perfect cube. I'll write down the question, the second one. Find the smallest value of p such that 288p is a perfect cube. So the term perfect cube, as you have seen, so it means that the value of p such that 288p is a perfect cube. That means when 288p, this value that we have been given, when you break it down into its constituent prime factors, these prime factors, their powers will be divisible by 3. So 288p, when we are looking for its prime factors, so the prime factors are 2 times 2 times 2 times. So when you break down 288 to its prime factors, this is what we get. So to simplify it, to arrange them according to their powers, we have 2 power 1, 2, 3, 4, 5. So 2 power 5 times 3 power 2 times p. So the next step is that if you are looking for the cube root of 288p, we can call it a perfect cube if the powers would be divisible by 3. But from our case, we are seeing that 5 is not, when you divide 5 by 3, you do not get a whole number. So it is not divisible by 5 is not divisible by 3. So we need to find out, since p is the value of the unknown, we need to add values to this expression right here that we have, such that our prime factors 2 and 3, their powers will be divisible by 3. So we are going to find the nearest prime factor. How many prime factors do we need to add so that we can get the smallest value of p? So when you're looking at prime factors, you can even just from your common mathematics, the numbers 1, 2, 3. So let's add 4. Our prime factors here, 1 is a prime factor, but in our case it is not helpful. So the smallest prime factors are 2 and 3. That's also what we have here, 2 and 3. So we can say 2 power 5 times 3 raised to power 2 times 2 times 3. This 2 times 3, we have given p the value. We are looking for the value of p. So we have gotten p is 2 times 3 by looking for the smallest value possible. So the smallest value possible by using the prime factors are 2 and 3. So you cannot have 2 times 1. So 2 times 3, we are saying that we have 2 and 3. So this is power 1, this is power 1. When you multiply 2 power 5 by 2, you get 2 power 6, and 3 power 3, 3 raised to power 2, that is by 3 times raised to power 1, you get 3 power 3. So we are saying that right now our powers are divisible by 3. So this is a perfect cube. The powers are divisible by 3. So 6 divided by 3, you get 3. That 2, that is, sorry. 6 divided by 3, you get 2. So 2 power 2 times 3 raised to power 1. So you get that it's 4 times 3, which gives us 12. So hence p is equal to 6. So we have found the value of p already. This is the cube root of the number that we'll get by substituting the value of p. I want to show you where that comes along. We found that p is 2 times 3. That is taking the smallest prime factors that we can use. We have gotten 2 and 3. So p is equal to 6. And 288 times 6 will give us 1728. So when you find the cube root, that is the cube root of 1728 can pick it from here. The cube root of is 2 raised to power 6 times 3 raised to power 3. Then you have 2 raised to power 6 divided by 3, 3 divided by 3 again. So the cube root of the number is 12. So we can see that we've gotten a perfect cube since the powers of these prime factors are divisible by 3. So with that, I hope you've understood what we are talking about when we are looking for the cube roots of a number by factor method. So when you're looking for the cube root of a number by factor method, remember that the prime factors, the powers have to be divisible by 3 for you to get a perfect cube. So we have an assignment. Find the cube root of the following. So this is an assignment. The second question. So with that, I hope you can see this is as the assignment for this exercise that we have done, finding the cube root of a number by factor method. So with that, goodbye.